Hello, this is a lecture for preparing the assignment for ICT based education faculty development program. This basically the course is on discrete time systems. I'm going to describe the various types of systems, classification, and how do you find out if the signal system is given, which kind of system it is. Basically, the discrete time system is any operation or some algorithm which are set of rules that are operated on a particular input signal which transform it to some another discrete time signal known as output response. Discrete time system can be represented by many ways: block diagram way, difference equation, impulse response, system function. Here, the form of the discrete time system given is block diagram. So this is the difference equation which has been implemented in the form of the block diagram. In this particular difference equation, the signal starts with the original signal x of n. So here the block diagram is x of n, which is multiplied by 0.5. So it's a scalar. Signal multiplier, adder. So there are different blocks are there. Now, discrete time systems can be classified into different ways: static and dynamic, causal and non-causal, linear, non-linear, time invariant, invariant, stable and unstable systems. Static and dynamic. System is said to be static if the output of the system at any time instant or for any sample, it depends upon the present input, not on the past or the future inputs. Otherwise, the system is said to be dynamic. And you need memory to store the future or the past inputs. So the dynamic systems are also known as a system with memory, and the static systems are known as memory-less systems. The causal system are the system whose output at any time depends on the present and the past inputs, but it did not depend on the future inputs. They are not anticipating. Causality is necessary for real-time implementation. But non-causal systems will depend on the present, past and the future inputs also. DSP, in a digital signal processing, most of the processing is done like a non-causal systems. They are all non-causal because all processing has been done on a store and forward form. The data has already been stored previously. Static systems are causal, but the dynamic systems can be causal, cannot be non-causal. So here some examples are given. Here this particular system depends upon the present input and the past, so it's a causal. There is no term, no input which describes the future input. Well, here this is y of n is equal to x of 2n. It's a non-causal system because y of 1 depends upon x of 2, so it's a future input, so it's a non-causal system. Time variant, time invariant system. System whose input-output behavior does not change with time are called time invariant, and the invariance property can be found out by these steps. First of all, determine the output due to the input, let's say x1 of n. Shift this output by k sample, so find out y1 of n minus k. Now determine the output y2 of n due to the delayed input. So you have to delay the input x1 of n by k. So it becomes x1 of n minus k. And then we can find out that what is y2 of n. If this y2 of n, which is known as y of nk, that is the output of the system due to the delayed input itself, if it is equal to the output of the original system delayed by k sample, if both are same, the system is time invariant. So here are the examples given which describe how to find out the shift invariance property of the system. Linear and non-linear systems. To find out the property whether the system is linear or non-linear, homogeneity and superposition principle are to be checked first. So, homogeneity says that if y of n is equal to is the response of the x of n, if I multiply the input with a scalar factor, let's say a, the output should also be multiplied, then and then system is known as homogeneous. Similarly, superposition principle says that if the output response for x1 of n is, let's say, y1 of n, the output response of x2 of n is, let's say, y2 of n, then summation of these output is the output of the system given by x1 of n plus x2 of n is an input. So condition for linearity is both homogeneity and superposition must be hold true. Then and then system is said to be linear. For finding out the linearity property, the steps are, first of all, whatever systems are given, find out y1 of n due to the x1 of n, find out y2 of n due to the x2 of n input, find out the output due to weighted sum of input. So you find out weighted sum of input itself. So which is ax1 of n plus bx2 of n. Just take these as an input to the system and find out the output. And in the second case, you have to just add these y1 of n and y2 of n by a scaling factor. So it is a y1 of n plus b y2 of n. So if they becomes equal to y3 of n, then and then we can say the system is linear. A system is said to be now the next type of system is unstable system. A system is said to be bounded input, bounded output stable if for every bounded input produces a bounded output of the system. And it is necessary that every LTL system is stable. Then and then we can work upon it. So stability is a desired property of the system. LTI, that is linear time invariant system. The accumulator function y of n is equal to y of n minus 1, which is the previous output, plus x of n. This is basically unbounded. It produces the unbounded output for a bounded input. Let's see, if we take x of n as a unit step in signal, the accumulator will blow up and it generates the unbounded signal. So accumulator is an unstable system. Every discrete time signal can be represented by delayed, advanced, or scaled version of impulse sequences, which is known as a unit sample sequence. We know that unit sample sequence are basically described by the delta n, and they are having unit impulse, so they would have an amplitude 1 at n is equal to 0. It does not exist anywhere else except n is equal to 0. So from this impulse, every signal can be represented by multiplication of that signal with the shifted and delayed or advanced version, the scaled version of the impulse sequence. So we can, this is known as impulse decomposition to represent the system. Now let's say the next is a convolution. Like an addition in a mathematics, which add two numbers. Convolution in a digital signal processing, it's combined two signals and generates a third signal. So basically, they accept the two signals as an input and generate the third signal. In a linear time signal, the response to a unit sample signal delta n is denoted by h of n. Then if your system is a linear time invariance, then the response of the system can be delayed by, if the input is delayed by n by k samples like delta n minus k, the output response of it will also be delayed by the same n minus k. If let's say h of n is the impulse response of the system. So if the impulse is an input, h of n is the response of the system. If we apply x of n as an input to that LTL system, the y of n is an output to the system. Then we can say The phi of an output response is represented or can be found out by output response for any input can be found out by this way, by taking h of n minus k multiplied by x of k and then taking the summation of these two for k minus infinity to infinity. So it can be achieved by following steps. First of all, find out the impulse response, shift the unit sample sequence h of n by k and find out its response h of n minus k, invoke the homogeneity and add using an additivity brings the result convolution. So this is known as a convolution, which is very important operation in BSP. It may be useful a lot.